Okay, so this is the problem about which most of the students are curious these days. It was considered to be a very tough problem. As you can see, it is the problem of IIT Advanced 2026. Two small spheres rolling on a larger sphere. But believe me, once we discuss the solution, you guys will realize that it's quite an easy problem. So let me just read out the problem statement without wasting much of a time. Consider a large disk of radius capital R and two smaller disks, each of radius small r equal to capital R by 50, lying on its circumference as shown in the figure. The smaller disks are initially in contact with each other with an angular separation delta theta between their centers. They are made to roll without slipping in opposite directions with constant angular speeds omega, 2 omega respectively, with the larger disk held stationary. The time tau at which the smaller disks are again in contact is, the options are now given. You can see the diagram also. So now I will start the solution and I will be going to the next page. So the most important part is that I have to redraw the diagram once again, which is necessary for the problem. So I have just reproduced the diagram, which I think should be clear to all of you. I start with this condition which was given. So this easily implies now the centers of the smaller disks move along a circular path of what radius? Just try to find it out. Just try to realize that the radius of the circular path in which the two smaller disks are moving is this is our equation number 1. It's not a tough problem, but to explain every part very clearly, I will divide it in a large number of equations. There is nothing to worry about that though. So when the two small disks are in contact, then the distance between their center is 2r. I think it is not tough to understand. This distance is 2r. Very clearly you guys can see so when we put the value of capital R in this equation, we can easily get so you guys can now see we can get rid of this small r and we have our second equation ready, right? Delta theta is equal to 2 by 51. And this sounds interesting because there are quite a few 51 factors appearing in the denominator in the options, appearing in the numerator in the options. So this is our equation number 2. Okay. Now the most important part of the problem, rolling without slipping. All of you have read that theoretically. When the two smaller disks are rolling without slipping, then their linear speeds should be given by because the angular speed of the angular speed of one sphere is 2 omega and angular speed of one sphere is omega. That is why we get these two equations, and these will be our equation numbers 3 and 4. Now, the magnitude of angular velocity of the center of the smaller disks having angular velocity omega about the center of the large disk. I repeat this part, please listen to it carefully. The magnitude of angular velocity of the center of the smaller disk having angular velocity omega about the center of the large disk is so we now put the value of V1. This value of V1 is to be put over here. And we should also realize that capital R plus small r equal to 51 into smaller. That is, we will be exploiting equation number 1. So this is our equation number 5. Similarly, for the second small disk rolling with angular speed 2 omega, the angular speed of the center about the center of the larger disk should be that is omega 2 should be twice omega by 51, and this is our equation number 6. Now, since we are running out of space a little, let me just switch over the page. But please don't lose track of these equations. We have 6 equations so far. Now, we need to take the concept of relative speed into consideration. A little bit of concept of relative speed is necessary. Whenever we talk about relative speed or relative velocity, we consider linear motion. But this problem very nicely fits the concept of relative speed in case of angular velocity as well, in case of rotating motion, in case of rolling motion as well. The two small disks are moving in opposite directions. So the relative angular speed of one disk with respect to the other is, let me just write it down. We must not have forgotten equation number 5 and 6 of the last page. So putting the values of omega 1 and omega 2 from equation number 5 and from equation number 6, we easily get This is equation number 7. Though in my view, equation number 7 needs a little bit of explanation. Why? When is the formula for relative velocity comes in this format? That is, when is vrel equal to v1 plus v2? When two trains are speeding up towards each other. Similarly, the two disks were rolling in opposite sense. That is why their absolute speeds or absolute velocities in magnitude has been just arithmetically added to get the magnitude of their relative velocity. This concept, which is often used in case of linear speed, is also absolutely applicable in case of relative speed, in case of angular motion as well. So going ahead, after this explanation, let the two disks again come in contact after rotating through some angle alpha. Now when the smaller spheres started rolling, then the angle between their centers were separated by an angle delta theta. And when they again come in contact, then similarly the angle between their centers will be delta theta. And this clearly implies the angle rotated, that is alpha, plus delta theta plus delta theta, it will be equal to what? It will be equal to 2 pi. Because in one complete revolution, 2 pi is the angle traced out. Such a simple concept, and yet there was so much of debate after IIT Advanced that it's a very tough problem. Believe me guys, it's not so. So this sums up equal to 2 pi, as I just said. That is alpha is equal to twice pi minus 2 delta theta, and this brings us to equation number 8. Okay, so we need to combine this equation number 8 with the equation number 2 of last page. So upon that is, we will put the value of delta theta. In short, we will be putting the value of delta theta over here. Upon doing that, we get not very tough calculation, isn't it? This brings us to our equation number 9 for this problem. Now, using equation number 9 and equation number 7, this is equation number 7, which is clearly in front of your eyes. Time taken for the two smaller disks to meet again should be given by, let me just erase these. As you can see, this is very simple. The time taken by the two smaller disks to meet again should be given by alpha divided by the magnitude of the relative angular velocity or the relative angular speed of the two disks. So we just put the value of alpha from here. And this was found out to be equal to 3 omega by 51. So finally we have got to the answer. It is which is the last equation for this problem, and it is equation number 10. So this is the answer of this problem. The two smaller disks meet after this much time, which is equation number 10. Two spheres rolling on a larger spheres. It was pretended, it was considered to be tough. But just see, just check out. I'll not take a lot of time of you guys. Just check out, what did we need? We need the basic concept of angular kinematics. We didn't even need any concept of angular dynamics or rotational dynamics. Only the basic concept of rolling motion, only the basic formula of angular kinematics were enough to solve this problem. Someone can say that you have used a large number of equations. That was just to make things easy for the newcomers or the beginners. But apart from that, there is nothing much in this problem. If the students do not get very nervous after seeing the question paper, then they can easily tackle this problem. Best of luck to all of you. Next time we will meet with another such interesting problem.
JEE Education Institute, near Baligang Station, Kasba. Admissions open. Call now.